Hello, everyone. Welcome. We are here today to talk about our newest feature launch, reinforcement fine-tuning on Amazon Bedrock with Nova Lite 2 with support for additional models coming soon. Today, we'll show you how we're going to democratize RFT and bring it to all developers on Amazon Bedrock without you needing to have deep ML expertise. My name is Shailendra, and I'm a product leader on Amazon Bedrock. I'm here with my colleague Shreyas, principal data scientist on AWS, and our customer Phil, SVP of engineering on Agentforce team on Salesforce. Let's start with some basics. What is fine-tuning, and why do we need it? Fine-tuning is a way to adjust an existing base model so that it fits your specific use case. For example, teaching it your company's tone, style, or with your own examples, like customer chats or documents, so it gains and learns to give you more accurate and consistent answers for your tasks, for your domain-specific tasks. But why do we need it? Why is base model not sufficient? It's because a base model, out-of-box base model, is trained on vast amount of internet data. It knows a little about everything, but not the specific details or tone or style that your company needs. For example, a base model may know how to write emails, but not your company's specific style or format. It can summarize text, but maybe not in your preferred tone or text with the accuracy you need. And that's why fine-tuning is needed. It teaches the model to perform the specific tasks for your domain more accurately, consistently, and efficiently than a generic base model can do. Many of our customers also use traditional supervised fine-tuning, also known as SFT. And we launched SFT in Bedrock a while ago. This is great. And SFT means training a base model on a set of inputs and correct outputs that you provide. In simple terms, you show the model how you want it to respond. For example, in this slide for classification task, you can see I love this is a positive sentiment, it's okay is neutral sentiment, and terrible is a negative sentiment. By training on many such examples, the model learns to follow your preferred tone and style, making the answers more reliable and task-specific. Although SFT works great for certain use cases like classification, summarization, but it does come with its own set of challenges. Number one, it's data hungry. Customers often struggle with high-quality data sets, labeled data sets. You must provide many clear and correct examples. And if your data is inconsistent or is biased, the model will learn those mistakes as well. It's expensive and time-consuming. Collecting, cleaning, and labeling training data takes effort, and training large models, as you know, requires compute cost. In other words, it's just very data hungry and requires large amount of high-quality labeled data sets, which is not possible for everyone. Number two, it is rigid. Models may memorize, but may not adapt. The model may become too focused on your examples. And number three, model drift, where performance degrades over time. And if your data rules change often, then you have to retrain the model each time the new data sets to keep it current. SFT also doesn't really do preference learning and aligning with human preferences very well. And we hear these examples from our customers. For example, we have 100 examples, but we need production quality models. Our model works great with some small set of examples in testing, but drifts in production. We want structured outputs with reasoning, but can't afford to annotate 10,000 or thousands of high-quality labeled data sets. These are the actual challenges that we have heard from our customers who have been using traditional supervised fine-tuning. But what if your model could learn from a very small set of examples, explore thousands of solutions automatically, and use the best solution to improve itself, and then continuously improve from the production data? Welcome to reinforcement fine-tuning on Bedrock. With RFT in Bedrock, we'll allow customers to easily create models that continuously learn from feedback and scoring, and as a result, deliver high-quality, intent-aligned outputs for your specific business needs. With our launch, we're going to democratize RFT and bring it to all developers using Bedrock with minimal ML expertise. Unlike traditional fine-tuning techniques, Your customers don't need massive amount of high-quality labeled data sets for training, or even need to have deep ML expertise to use this feature. RFT explores multiple solutions, scores them, and then uses a feedback-driven learning loop, which models improve iteratively upon time based on a reward signal and reward function that you choose. Let's take a look at this example. In this customer query, customer service agent is interacting, and customer said, I want to cancel my subscription. And model here explores multiple solutions responses. And response 1 says cancel. It's helpful, but it's abrupt. I won't like that response from a customer service agent, whether it's an automated agent or a human agent. Response 2, it says understand, but may I please ask what prompted that decision? As you can see, this response is empathetic and will score higher based on the reward function that I will create. Response 3, okay, here we go. Please fill out this form. And as you can see in this use case, model is exploring multiple solutions which will be scored based on your reward function and which will be used to improve the model weights. And what happens in RFT, the system actually explores multiple solutions that you just saw and then collect the reward signal on them and then exploit the best scoring ones by shifting model weights towards those patterns. Exploration ensures that new solutions are tested and explored, and exploitation ensures that the model increasingly prefers those that consistently yield higher reward, striking a balance between exploration and exploitation techniques. Now let's see how this RFT works in Bedrock. It's pretty easy. 3 simple steps. Provide your data from multiple sources. We'll see those sources. Number 2, define what good looks like via our out-of-box templates. You can create your own custom reward function as well using a Lambda. And then start training. And once the training is finished, deploy the fine-tuned model with our on-demand inference, pay-as-you-go, with no ML expertise required. So here we are. You can go in Bedrock console. On the left nav, you will see tune. So you select custom models. And then click create reinforcement fine-tuning job. Next, upload your data. And you can choose to upload data from your computer or your S3 file, or provide access to your model invocation logs, all in the JSON format in the OpenAI chat completion format. Here you can see you're uploading the data from any of those sources. And then next, let's define what good looks like using a reward function. Basically, we'll give you 2 options with some out-of-box and editable templates. Model as a judge, along with evaluation rubric, which you can edit, and then a Lambda function for verifiable rewards, which you can also customize and edit. Here you can see a model as a judge. We bring you some out-of-box templates for a variety of tasks like instruction following, summarization, chain of thought reasoning, RAG, Q&A, faithfulness. We also provide you evaluation rubric. You can edit this evaluation rubric for the judge prompt. Option 2, provide you RFT with verifiable rewards through custom Lambda function, which you can edit. And once you select these and start your training job, we also give you visibility into the training metrics. For example, training rewards, validation rewards, the episode length for training and validation. Once the training is complete, you can just deploy it, the fine-tuned model with RFT with on-demand inference. We have a token-based pricing for inference that it charges based on the number of tokens processed. For Nova Lite 2, our pricing for RFT fine-tuned model inference is the same as base model inference. And for training, we're charging $1 per hour. Now, Shreyas will actually show you a working demo of this feature. Shreyas.
Thanks, Shailendra. So what's coming up next is we're going to show you how easy it is to get started with reinforcement fine-tuning. And like Shailendra said, it doesn't expect you to be an expert in reinforcement fine-tuning. You don't have to be a scientist. But you do have to understand the basic 3 steps, right? 1, have your data ready. Number 2, create your reward function. And number 3, start your training, right? So let's get started with the demo. So to get started, you first go to your console. You can go to your console today. You'll see a new option for when you want to create a custom model called reinforcement fine-tuning. The first thing you want to select is what model you want to fine-tune. We're selecting Nova 2 Lite here with more open source models coming soon. We're also going to select this JSON-L file, which is our data set. And you can also select an S3 location or invocation logs. But what does this JSON-L form, data look like? So we're going to go through two quick use cases. One is FinQA, which is a financial Q&A data set. And this is just one view of that data set. There's multiple records in this data set, and that's what you see inside the JSON-L. This is a nicer view of it. Inside one of those records, you see a really complex prompt, right? You see some table in there. You have context about financial information and performance from 2016 and 2018. And the question we want to ask and we want to train the model to do well at is, what is the total operating expense in 2018 in millions? This involves table understanding. It involves long context. It involves mathematical calculations, as well as matching up to an exact answer that you want your model to be trained on. Here's a slightly different data set. This is a multilingual data set called CHAPSA. It's a sentiment analysis data set, something that Shailendra touched on earlier on. For this, you want to be able to analyze multiple languages, think through your reasoning, and then understand what the final sentiment is going to be. Here as well, you can exactly match up the sentiment that you want your model to train over. So you could have thousands of these records, right? The second main step is creating that Lambda function for your rewards. One of the ways to do your Lambda function is to write custom code, and we have nice templates that you can use. But if you want to write your own custom Lambda function, you can do that as well. So that's what we're scrolling through here. For verifiable rewards, you can also down select some pre-templated Lambda functions. This one is for format and constraints checking, so maybe you need that for structured output, for JSON outputs. You can also have one for math reasoning, which is a pretty common use case. And when you create your job, this Lambda function is going to be created on your behalf. You can do it on your own as well, but in this case, this is the full Lambda function. You have full control over what happens inside the Lambda function, but all you have to do at the end of the Lambda function is to return the reward scores for each of those samples that comes into the Lambda, right? So that's the only requirement. And in this case, we're just highlighting that you can walk through your samples and return a numerical score for each one of the records. So we'll go back to the console for a bit to explore this option 2, which is using a Lambda function that has AI feedback inbuilt, right? Rather than writing your Lambda function entirely again, they have some nice templates. You first choose your model that you want to apply with this template, and you can down select on that drop down 4 different reasoning or LLM as a judge kind of templates. So that's instruction following, summarization, reasoning evaluation, and RAG faithfulness. And each one of those corresponds to a rubric that we have tested and benchmarked against a wide variety of problems. So for example, with what we're seeing here is a rubric which is simple text. It's just going to describe how you want to score each one of the inputs that are coming in. We'll take a look at another one, which is instruction following. Here we have a different set of, a way to score the model, and we also want to cap the final score from 0 to 1, which is not necessary. You can have any score, but it's just good practice to do that as well. Once again, when you create that Lambda function, it's going to entirely create your calls to Nova Premier in this case, which is the model that we selected as LLM as a judge. You can also select GPT OSS 120B. There's a few other options that you can set up. So obviously you need some place to put your output data. This is where your training logs and metrics can go to. There are important hyperparameters that you can set visually on the console. So that's number of epochs, the learning rate. Here is set to 1e minus 5. You can set the number of training samples per prompt and the evaluation interval, or how often you want to actually evaluate your current model with the validation data set. Finally, you can create a role and then hit create. Behind the scenes, this is creating your Lambda function for your reward, your role, as well as starts training. So now remember, your training can take some time, right? So training is going through all of your examples. It's calling your reward function repeatedly when you have to train your model. And a few hours later, you will see training metrics. right? So in this case, we're seeing training rewards and validation rewards, and you can see that the line is trending up, which means the model is learning, your reward score is going up, both on the training side as well as the validation set. You also have other metrics that are useful, like train episode length, which in this case is the average number of prompt tokens output. You also have gradient norm and critic advantages that are very useful for, for example, your data science team to kind of debug what's happening behind the scenes. Lastly, once you've finished your training, you want to see how it actually works. And so the way to do that is to set up inference. What is really exciting is that you can actually set up on-demand inference, and you don't have to set up provision throughput. And what that means is you only pay for the tokens in and tokens out, right? So in this case, we're going to give it a name. So it's RFT model on-demand V1. And the model is already pre-selected. This is the model that got fine-tuned with RFT. You can also choose other models, but in this case, we're going to choose the model as pre-selected, hit create. And that's going to take a couple of minutes. So what the video is going to show is an example of a model where we already have this on-demand inferencing already set up. So that's the test fin QA example. That's the first data set that we're looking at, which is the financial services Q&A example. You can hit test and playground, and that opens up the familiar playground that you've seen in the Bedrock console. I'm going to paste in here an example financial Q&A data set from the test set. You see a table in there, you see a question, and then you want to match up to an answer, right? So as you can see, the model's already started. This is not, we don't speed this video up. This is actually real time. In 3 seconds, you get back the full answer based on this really complex financial services question. On the left sidebar, you can also configure some inference parameters that you're looking at right here. Another really interesting thing to do when you're comparing with your base model is to hit that compare mode toggle up there. And we're going to go back and select the Nova 2.0 Lite, that was the base model, to do a side-by-side comparison of what improvement was made due to RFT. Right? So once again, you see it's equally performant as the base model. You also only pay for the tokens in and tokens out of the base model rate. Right? So super easy to get started. And with that, I will hand over to Phil. And Phil from the Agentforce team and Salesforce will talk about Agentforce as well as how they've been using RFT. Phil?
Thank you, Shreyas. Hi, everybody. So I want to start with a little bit of historical moment here. About a year ago, December, there is a paper that came out. Some of you may have heard of it as the DeepSeek V3 paper, December last year. And then in January of earlier this year, another paper came out from the same group called the All-One paper. And behind the technology there that really, I think, took down NVIDIA by 25% when the paper came out, was the technology that we're going to talk about today. So in case you're wondering, like historically, where does this come from? So I want to use this time to kind of describe why something so technical, right, is impacting a company like Salesforce and the type of enterprise AI system that we are building. So in front of you is a slide that, for those who come to Dreamforce, it's a slide that is probably shown about, 20,000 times. And what this is about is Agentforce. What is it? Well, it is an enterprise AI system, enterprise AI platform. It is not a new product. All that it is a new veneer over all of the Salesforce capabilities and platform and acquisition that we have made over the last 26 years. Except we made it agentic. Agentic meaning all of those become tools, as well as be able to take advantage of some of our recent investment into Data Cloud, all the acquisition we have made, Tableau, Slack, etc. So in Dreamforce, about a month and a half ago, we announced the next version of Agentforce. This is the 4th version that we have, called Agentforce 360, right? Who doesn't like 360? So at the heart of Agentforce 360, the next evolution of Agentforce, we are serving via this agentic platform, both front-end customer-facing applications. This is the Agentforce service, sales, marketing, commerce, and so on, as well as the back-end operations. And we announced very excitedly our brand new Agentforce supply chain, Agentforce revenue management, Agentforce IT services, ITSM, etc. And then In addition to providing automation via agents, we are providing support for many employees through agents that are now living natively in Slack or Slackbot, in case you haven't tried that, or Agentforce HR services. So that's what we mean when we talk about Agentforce. And of course, behind the scene, there are all kinds of tech. So we're going to look at all of these different layers of tech and see where does the technology that AWS is announcing today helping us. In particular, we're going to look at the layer that is calling the trust layer. We use many models. We provide, as enterprises, they wanted to have the option to select any models that they want in a way that is trusted, right? So we are providing the wrapper to make sure that it works for all the agentic applications that you have in mind. So the use cases that come to our attention earlier this year after we read the famous R1 paper is, hey, the large frontier models that are out there, the GPT 5.1s, the Claude 4.5, those are really awesome, but they generally have long latency. So if you have latency-sensitive applications, like voice applications, you probably want to use something that is a bit more efficient. So our criteria is very simple. We want high accuracy, but we want low latency, along with high explanatory power. And so the need drives us to look into creating our own fine-tuned small language model, this is what the industry usually calls it, so that we can get this balance of high accuracy, low latency, while providing low cost, right? Because we're able to host it and manage it ourselves on AWS. So the particular model that we have has now been released is called the text eval. Internally, we call it text eval. So this is our in-house LM as a judge model. There's a patent number behind that and so on. Currently, on a monthly basis, it serves roughly 13 million queries and is expected to double and triple, right, over the next few months. So the model is driving a number of applications. Guardrail applications, the instruction adherence, task resolution, citations, automatic inline generation of citations, as well as to provide response quality assessment in our testing center product, which is our observability and testing experimentation platform. So the methodology that we went through, exactly like Shreya was describing, there are a number of things that we were doing. This is before this amazing, easy-to-use product is available. This is quite a bit of work. The base model is a GPT OSS 20B, and it is being fine-tuned using a data set that is both publicly available as well as synthetically generated, SDG data. So the pipeline went through a combination. It's a mixed model, training model between SFT, except with a reduced data set, along with so-called GRPO, which is this reinforcement fine-tuning technique that Shreya has talked about. And the result is text eval, literally within hours, right? Rather than previously would have taken weeks. So here's the slide probably many of you are looking for those who are on the science side. So on the very first row, the base model that we are comparing against is the GPT-4o 1120 version, okay? So I want you to go all the way to the right, look into the F1 score. Think of it as an accuracy score, if you could, on two use cases. One is instruction adherence. How likely is the response adhere to the instruction that you have given it? And GPT-4o F1 score is 88%. Completion is task completion score. So the GPT-4o frontier model last year was 83%. That's okay, not bad, but it costs a lot, for sure. Now, the base model for the GPT OSS 20B, now remember, the 4o is probably a trillion parameter model, so a 20 billion parameter model, of course, is going to perform worse. And indeed, 64% for adherence, 79% for task completion. So standard technique number one that Shreya and Shalesh introduced using SFT, supervised fine-tuning, was able to, using the text eval, able to uplift it, doing pretty well, up to 93% F1 score. Now, if we apply this reinforcement fine-tuning, natively, the instruction adherence get up to 95%. But for task completion, it's only 79%. So you're like, wait a second, what is going on? And so the next line is the secret sauce, if you could. So it turns out, counterintuitively, if you bring in data sets that are beyond just instruction adherence, but that's two different tasks, instruction adherence and for task completion, it actually improved both. So the non-intuitive part is it also improved that for instruction adherence to now 97% and 95%, both of which are significantly better than the frontier model GPT-4 at a fraction of the cost, less than 10%, all on AWS. That's pretty good. So the next step, as we test this out, and this is now in production, of course, we're going to standardize more and more of this. And in fact, we're very much looking forward to beyond small task-specific models here. We're looking into our reasoning model. Perhaps there is now a better reason for us to move to something that is cheaper, faster, and perhaps even better. And so the one final example I'm going to give to you here. Reasoning is probably the final frontier when it comes to making agents able to adhere to the constraint that you want to give to it. As part of the Salesforce Agentforce 360 launch, we launched a brand new way of handling enterprise reasoning that we're calling the agent graph. And so the two-sentence summary is we externalize complex reasoning into a graph of specialized agents that are coordinated through the Agentforce orchestrator. And the key trick here is that the state transition from one specialist agent to the other is controlled by a finite state machine, an FSM. And for those who came from the CS world, this is about as deterministic as you're able to do it, while retaining the natural sounding voice, if you could, of a LLM-based agent. And so to do this, every one of the specialist agents here can make use of a reinforcement fine-tuning language model as its reasoner. And so we're working through that over the coming year. Finally, so just to let you take a look, we're looking at the trust layer here, but you could imagine over the next years and so on, as many of you in the room will help revolutionize how enterprise agents will work. The impact of reinforcement fine-tuning could impact every single component on this slide. And with that, I'd like to pass it back to Shailesh to conclude.
Thank you, Shreyas and Phil. So you just saw how our reinforcement fine-tuning on Bedrock, how it works, and how our customers like Salesforce are using it for their use cases. Today you will see reinforcement fine-tuning in Bedrock with Noah Light 2 model, with support for additional models, including open weight models coming very soon. So in summary, 3 main reasons for you to consider and use RFT in Bedrock. Number 1, ease of use. We have done all the end-to-end automation, so you don't have to worry about any infrastructure setup. You don't need any deep ML expertise. Number 2, better model performance. As you saw in Salesforce and in other experiments we've seen with gains of up to 60 to 70% on an average compared to base models with the use of RFT. And number 3, visibility into training metrics. So you understand what's going on, and then once the training is complete, once your RFT fine-tuned model is ready, you can deploy it with on-demand inference and only pay for tokens that you use. Now, before we wrap up, I also wanted to take a moment to talk to you about the innovation we have been doing on the Bedrock side overall. We continue to bring the latest and greatest models, latest foundation models on Bedrock, giving you enormous model choice. And we'll continue to invest in it more and more to serve you all better and better. Number 2, as you saw with RFT launch, we will continue to double down on model customization. Earlier this year, we GA'd the capability of model distillation, and we also launched on-demand inference for custom Noah and Llama models. Number 3, we have been investing heavily in agentic AI, and we recently GA'd Agent Core. Hopefully, you also saw additional announcements of Agent Core, agent evaluation, and policy features. And number 4, we continue to launch new features in Bedrock Guardrails, and we recently launched the support for coding-related use cases as well in Guardrail. We will continue to make Bedrock the most innovative GenAI platform in the industry, so you all can build the most powerful, useful, and efficient GenAI apps for your customers. Thank you.